Hello everyone, welcome to Ocean Cafe. Now in today's lesson, we are going to differentiate trigo functions, and this is something usually students were struggling with. So let's do a quick test and see how many can you differentiate today. Okay, so let's start with level 1 questions. Over here we have y equals to cosine 3x. Now to do this, make sure all of you have this basic. So we need to know, all right, when we differentiate sine, we get cosine. Cosine equals to negative sine. And when we differentiate tangent, we get secant square x. So this is something basic whereby all of us must know this very well. Now, so to differentiate cosine 3x, something whereby I use in class very often to guide my students is this. I like to use this phrase, we differentiate the outside, then the inside. So what do I mean? So over here, all right, let me do the color code. So I will differentiate the outside. So that means when I differentiate cosine, I will get sine. So which means this will give us dy dx is equals to sine 3x. Then now I move on to differentiate the inside. So the inside now it is actually 3x. So for us to differentiate 3x, we get the 3. So this is easily done. Okay, very good. Now that we have done level 1, let's move on to level 2. Now, so level 2, we are going to differentiate this, which is sine bracket 2x cubed plus 9. So again, all right, we need to know the basic well. So over here, I'm going to apply this again. So I differentiate the outside, then the inside. So the outside here, I'm referring to sine. So which means if I differentiate sine, I will get cosine. So I just simply write it down. So outside is done. So once this is outside is done, I will need to look at the inside. So the inside, which is a function 2x cubed plus 9. So how do we differentiate 2x cubed plus 9? And this will give us 6x squared. So again, this question is easily done. Okay, very well. So now that we have completed level 2, let's move on to level 3. So over here, we are going to differentiate y equals to sine square bracket 4x minus 5. So again, we will need to know this basic. So what we observe here is there is an index, right? There's a sine square. So each time when we have a square term, which means we can actually apply chain rule. Yeah, so to do that, again, I'm going to use this term, differentiate the outside, then the inside. So what I'm going to do is I'm going to apply chain rule over here. When I differentiate outside, yeah, so which means I'm looking at sine squared for x. So to do that, I'm going to bring down the power 2, and then I have sine 4x minus 5. Now, so once this is done, I will need to look at sine. So again, if you look at the uh, formula here, right? If I differentiate sine, I will get cosine. So which means if I differentiate this function here, I will be able to get cosine 4x minus 5. So this is still not complete yet. Why? Because we will still need to differentiate the inside, which is 4x minus 5. So to do that, I will be able to get 4. So by putting all these together, I will have 8 sine 4x minus 5 and cosine 4x minus 5. Now, usually we can just leave the answer here like this, but I'm going to challenge you a little bit. All right, so see if you are able to simplify this function. So if you know your double angle very well, all right, you may be able to simplify and to see, all right, that I'm able to get 4 sine 2 4x minus 5. So this is basically from double angle formula, because double angle formula tells me that 2 sine theta cosine theta will give me sine 2 theta. So hopefully this will give you some insight. Okay, very well. Now we are ready to move on to level 4. So over here, you notice that the expression get a little bit more challenging. We have done sine and cosine. So over here, we have tangent. So let's take a look. All right, so if I have tangent, so which means I know that when I differentiate tangent, I will be able to get secant squared. Yeah, but over here, there is an index. There is also a function that is involved 2x plus pi within the tangent function. So let's see how can we differentiate this. So just a quick recap over here, pi is not an unknown. Pi here is actually a constant. All right, so when we differentiate a constant pi, we actually get 0. So these are some basic that we will need to know. Okay, so let's move on. So again, I'm going to apply this. I differentiate the outside, then the inside. So I'm going to apply chain rule again. So which means dy dx, this will give me 5, and then I bring down by using a chain rule. So I have 3, right? So I bring down the 3, and this will give me tangent square 2x plus 3. Now, once this is done, I will want to just focus on tangent 2x plus pi, and I will ignore the index. So by looking at this, I know that differentiate tangent will give me secant square. So putting this together, I will have secant square 2x plus 3. Now, once this is done, I still have one last step. Why? Because I need to look at the inside. So the inside here, I'm referring to 2x plus pi. So when I differentiate 2x plus pi, I will get, yes, a 2. So putting all these together, so what we are going to do is just going to simplify. So I'm looking at the 5 and the numeral, 5 and 3 and 2. So putting all these together, 5 times 3 times 2, and this will give us 30. Yeah, so with this, all right, I will have secant and tangent. I just put them together, and this will give us the answer. So do you manage to get it right? So if you do, congratulations. Well done. So let's move on to the very last questions here at level 5. So over here we have secant 2x. Now if you take a look at secant 2x, and if you recall, the formula here, right, you will notice that there isn't any formula to give us the derivative of secant 2x. So what are we going to do? Yeah, so what I'm going to do here is I'm just simply going to apply what we know about secant. So we know that secant can be rewritten as cosine 2x. Now, so usually what happens here is, all right, students will tend to write down cosine 2x or 1 over cosine 2x as cosine to the power of inverse 2x. Yeah, then you realize that you can't go further. All right, so what I'm going to illustrate here is I'm going to use quotient rule, all right, to illustrate how to get the answer. So to do this, let's dive in. So I have dy dx, so I'm going to have, all right, v, which is cosine 2x, and then I differentiate u, which is the 1. I differentiate 1 will give me 0. Then I minus u, which is a 1, and then I differentiate cosine 2x. All right, so which is this v. So when I differentiate cosine 2x, this will give me negative sign. So this will give me negative sine 2x, and then I differentiate the 2x again, I will get 2. So this is what I have here for v du dx minus u dv dx. Then I'll just simply continue with the denominator. So this will give us cosine square 2x. Now what I'm going to do is I'm just going to simplify this expression. So this will give us 2 sine 2x over cosine square 2x. Now, you can always just leave the answer here like this, but then you will notice that this isn't the expression that we will get to see very often. So I am going to apply a little bit of trigo skill. So what I'm going to do is I'm going to split the function, right, the expression to sine 2x over cosine 2x, and then this is the same as multiplied by 1 over cosine 2x. So you get to see the cosine 2 as a denominator. I split to get cosine 2x times cosine 2x. Now, so if you make an observation here, right, now what is sine 2x over cosine 2x? If you are familiar with the trigo function, and you know that this will give you tangent 2x. Now let's take a look at 1 over cosine 2x. What does this give us? Yes, this actually gives us secant 2x. So this is how we get the expression, and this is usually the expression that you get to see when you differentiate y equals to secant 2x. Yeah, so hopefully this will give you an idea, all right, how to differentiate some common expression on trigonometry. So as we end the lesson, I just hope that all of you can remember one phrase, which is an important phrase that if you know this, all right, it will going to help you uh, for a long period of time. All right, it will help you a lot. So that will be, always remember, you differentiate the outside, then you differentiate the inside. So if you can remember this tagline, is going to help you, all right, very well. So with this, I thank you. So with this, I hope you find this video useful. All right, thanks for watching, and I will see you in the next video. All right, bye.